Okay, today's lesson, lesson 72, is a rather lengthy lesson, so I'm going to go as quickly as I can. It encompasses two different things. The first is factors that are sums. That's pretty easy, and we'll skip right through that. And then pyramids and cones, which will take a little bit longer. All right, you know we've been factoring, and here you'll notice we said that we would take out any expression that they have in common. Well, if you'll notice here, all three of these expressions have this in common. So we're going to just factor that out. That's the common factor. And then we're going to see what do we have left after we've done that. Well, we'll have x squared minus x minus 6. So we're just going to bring this down and leave it like it was. And then we're going to factor this. All right, so remember this is a 1 here. So we're going to need the factors of 6, and those would be 1, 6, 2, and 3. 2 and 3 is the only pair that can possibly give us a negative 1. So one of those needs to be negative and one needs to be positive. So I'll do that. Now, the higher one needs to be the negative so that when we add, it will take that negative sign. So we will say x plus 2, x minus 3. All right, in this one, we have this, and this all in common. So again, we're just going to factor that right out. See what we're left with. We would have x squared plus 9x plus 20. This is easy because it's all positives. Bring this down, and then we're going to factor this, x plus, the factors of 20 that will give us 9. Well, you've got 1 and 20, 2 and 10, 4 and 5. 4 and 5 is the winner, so it doesn't matter where you put them because they're both positive. So this is your factored expression, x plus y, x plus 4, x plus 5. All right, we're going to do one more, and we're going to see what all of these have in common. Well, as I look, I see obviously that they all have x minus 1, but I'm looking closer and I see that they all also have an m somewhere. So I'm just going to take out the m, x minus 1. Now I'm finished with that. What do we have left? We have x squared plus 7x plus 10. We'll bring this down, and this is what we're going to break apart. X, there, everything's positive. The factors of 10 that would give us 7 would be 5 and 2. And there you have it. All right, moving on to pyramids and cones. Pyramids and cones have their own formulas for area and volume. Let's look at the actual parts of the pyramid. Here at the top point you have, that's called the vertex. This is called a lateral face. Right here, all of this is the lateral face. This is the slant height. Notice it's called that because it is at a slant. And from that we can determine this would be our two numbers, base times height, that would form the right angle. Here we have this from the vertex down. This is a lateral edge. We call this the altitude or the height. And again, this is the base. So a pyramid is classified and named according to whatever shape its base is. If its base is a rectangle, it's a rectangular pyramid. If it is a triangle, it's a triangular pyramid. And if it's a square, it is a square pyramid. Now a cone is like a pyramid, except that when its base is closed, here you've got an open base, like if you cut it and just laid it out flat, then it would be a curve instead of a polygon, a closed curve, okay? The curved surface between the vertex and base is called the lateral surface. So when we're going to have to find lateral surface area, this is what it's going to be looking like. So you can picture that in your mind, okay? All right, and just like in a pyramid, here we have our base, our height, and then again, this would be the slant height. All right, so we've gotten our area of the base. 9 times 7 is 63. And the formula for volume of a pyramid is 1/3 the area of the base times the height. All right, so we need 1/3 times 63, which we now know is the area of the base, times the height of 8. All right. When we multiply all of that out and then divide by 3, we're going to get 168 inches cubed. In this particular one, because we need 1/3 of 63, well, 63 divided by 3 is 21, and then 21 times 8 is 168, so a little easy to do in your head. Okay, so here's a cone, and we're going to try to find the volume of this cone. So the first thing we have to do is find the area of the base, and we know that the radius is 6 feet, and that our formula is pi times the radius squared, so it would be pi times 36, and then we would take 1/3 of that, and that's the formula, 1/3 of the area of the base times the height, so 1/3 times of pi times 36, and then we need to times that by the height, which is 8. So this would be 12 times pi times 8 equals 96 times pi, which is 301.44 feet cubed. Volume is cubed. All right, here we're going to find the surface area of this pyramid. This is looks like a rectangular pyramid. All right, so remember the surface area is the square base, okay, it's a square, plus the area of each lateral face. Now, this one, it looks like has 1, 2, 3, 4 lateral faces, okay? All right, so the base, if this is a square, then the base is going to be 6 times 6, which is 36. The lateral face equals the area of a triangle. See, we've got a triangle here. Our height is 5, and then we are going to have 6 here. So 6 times 5 is 30. We divide that by 2, which is 15. And 15 times 4, because there's 4 sides, is 60. So I'm going to add the 36 from the base plus the 4 sides of 15 each of 60 for a total surface area of 96 centimeters squared. All right, here we're told to find the surface area of this cone. So the surface area equals the area of the base, again, plus the lateral surface area. And if you remember earlier in the lesson, I showed you the one that had been cut, and the surface area was laying out like this. All right, so our formula, pi r squared for the area of the circle, and then plus pi times the radius times L, or the slant height. All right. 8 is our radius, so 8 squared is 64, pi times 64. And then here we have pi times the radius times the slant height of 10. So we have pi times 80 would be 64 times pi plus 80 times pi would be 144 times pi, which comes out to 452.16 meters squared. And you can find all of these formulas and all of these examples actually are in your book. You can go back and refer to it and look step by step again if you need to. Now let's work our practice problems. Alright, now this says factor and begin by factoring the greatest common factor. Now remember, we've got a plus b is common to all three, so we're going to just take that out, and then we're going to see what do we have left after we do that. Well, we have x squared plus 8x plus 15 equals, alright, a plus b. Let's factor out twice, and we would have x and x. Everything's positive, so that makes that easy. And the factors of 15 that would add to 8 would be 3 and 5. Alright, b, we have, look really close, we have m minus b. But if you look, we also have a c in every single term, so we're going to take it out too. And then what do we have left? We have x squared minus 2x minus 24. So that's what we're going to break that down right there. We'll just bring this down, m minus b, c. X, we're going to need one negative and one positive if this is negative right here. So we'll put a positive and a negative. Alright, the factors of 24 that would add or subtract to 2. Well, 1 and 24 won't do it. 2 and 12 won't do it. 4 and 6 will do it. So that's my choices. But now I have to ask myself which one of those needs to be negative. In order to get a negative 2, when they're added, it would have to be the 6. So x plus 4, x minus 6. Alright, C says find the volume of the right rectangular pyramid. So we're going to find the area of the base, which would be 10 times 8, which is 80. And then we're going to say 80 times, alright, so gone ahead here. We're going to say 8 times 10, which is 80, and then that times the height is which is 12. 80 times 12 is 960. Alright, and then the formula for volume is 1/3 of that, because pyramid is has some triangular shape to it. So 1/3 of 960 would be 320, and these are in centimeters, so it would be centimeters cubed. Alright. Alright, so in this one, in let's see, D, it says a right circular cone has a base of radius 9 meters and a slant height of 15, and find the surface area. Alright, the first thing we have to do is pi times radius squared to find the area of the base. So that would be pi times 9 squared, or pi times 81. Alright, and then we have to say pi plus pi times 9, the radius, times the slant height of 15, plus pi times 15 times 9 would be 135. So pi times 135. So here we have 81 plus 135 is, let's see, pi times, 6, 216. Pi times 216. And then when you multiply that on your calculator, you will see that pi times 216 equals 678.24 meters squared. All right, good job. I will see you back next time for lesson 73.